And here we are. Let me settle everything up for us to get started. And opening up the chat over here. If anybody comes around. Closing a lot of things. And where is our app? Hey, Fabian Lars, my Tauri teacher. Putting down my app over here and let me open where I stopped. So as usual in the beginning, like it's not the second time we do this, but as usual, we are gonna get started. I'm gonna start up by showing you what's the end goal. I made a few improvements from on the last stage. Like, to be honest, the app is not entirely done yet. I just keep learning as we go. But now we're close to the end functionality. Let me go on and share up my screen. So this is the app right now. It's called Pulsar. It didn't have a name before. So it's a dependency scanner where if you come over here and select a scope, it's gonna open up our native dialog window, and then we can just click up a scan. So this is gonna take a few seconds. So I had 7 directories of projects. It's scanning 3.26 seconds. I can check over here the name of the project, what's the path of my node modules, how big it is, and then as we go, we can close it up, and then we have this confirmation dialog from our native system, where we can decide, yeah, we're gonna delete or not. As you can see, there's already some optimistic mutation over here. So as I click delete, my node modules is gone. Even if I scan it once more, now I have only 6, still not updating the result as we go, as we take it away, but they are all here. So we have a NeuroRust demo here right now, and NeuroRust is gone. So I can come over here and say, oh no, but maybe Fabian Lars wanna see it again. So I can cancel and it comes back right up. So this is where our app is at the moment. Let me see one thing here. It seems that, yeah, okay. Everything seems okay with our stream. And now I'll open up the current state that we have for this app, where we ended up. Let me see, open, not in a new tab. I cannot do this with the file system dialog. Let me open my terminal. And then I get to my crab stream, and then I'll do the Pulsar stream. Just now, here we are. And let me open up a little bit more on the screen side. Ta-da-da. Awesome. So let me give you a new tour just to recap where we left things off. There was a little bit of issue here on now it seems okay. Let me bring back the status bar. So our Rust dependencies is over here. We have everything working. And done. So we have the root of our project. In here we have all the Tauri related stuff. So our main RS is where things happen. We had a few issues in the end of the last stream where I had a bad type annotation here, so I just removed it as usual, and it just works because we're not actually returning anything at the moment. This is not being used. This we're gonna do on our next stream. On this one, I'm gonna set up the environment so our app looks a little bit closer to this one. That's our end goal. So for now, I need to close up this. So closing the app actually frees up the ports, and then I can run the current state of things on this one. So it's gonna take a little bit because we don't have any more the artifacts that were compiled. There you go. So this is where we ended things in our last stream. And let's start by getting it some proper state over here in my screen. And we can go back, and now I'm gonna start working on the interface of this. So let's clean it up. There's a lot of styles that we don't need. There's a lot of icons we actually don't use. We already have the image for the background, so we can start cleaning this up, because on the next stream on Monday we are actually gonna add the styles for we're gonna add the Rust logic, which is quite a lot. If I show you up here about my working state of things, we are gonna have we're gonna work a little bit on the main, so there's quite a lot of stuff to do, and we have the utils that are, we're gonna order the list. We're gonna do a bunch of stuff on the next stream. This one, I want us to get the front end in a good shape for this thing to start looking like an app, which is quite not at the moment. We have a little bit of things here, like Tauri is already working because it's awesome to get things working. It's kind of easy to do this API call and stuff like this invocation, but we can do much better on the UI side, and that's actually what we need to do at this point. So getting started, it's like in the front end side, it's basically a SolidJS app. So there's not much we can do. Oh, I just realized my camera is completely off. Yeah, so now it should be better. Let's see. Yeah, okay, so now I'm centered. I'm sorry. And hey Parker, how's it going? And let's get started with this. I'm just getting in the way of myself. So we already have Tailwind set up, I believe. Yes, we do. So this means we can just start deleting stuff and fixing up some things. Let's see, where did I... We have a few CSS classes that I want to make available for us. So back to our CSS. We don't need any of this. What we need actually is to add the Tailwind stuff. Tailwind base, which is going to bring all the base and the CSS, the pre-flight CSS and stuff like this. Tailwind components and the Tailwind utilities. We are not going to need this one anymore. And what I want at this point is, is to have our base classes. So this is gonna add our space from assets over here. Not quite. Yeah. So this is gonna add our space from the assets over here, And this is gonna apply a few Tailwind classes like the background cover, some Z index. And then these classes we're gonna need like much later, but they're already here. They're gonna be useful. So just like that, we get our space background, which is pretty great. And then we can start changing some of the stuff over here. So we can actually delete all this stuff and start from scratch. The scanner are not gonna be necessary right now. And then let's go straight with a main. And then we're gonna have our header over here, an article, and inside right after the article we get a footer. The main needs a few classes, and remember, if you're looking at this, it does look a lot like React, which is the most popular one, but we're dealing with SolidJS here, so I don't need to do those class names. We can just use class. And this autocomplete is powered by the Tailwind extension on my VS Code. We're gonna have a fallback background, and with this opacity, set up the default font color, and then the grid roles, which is what does the magic for me, is this like little one-liner where I say the header is gonna take the size that the header wants to take in height. The article is gonna fill up all the space, and the footer is gonna take only the space that it needs. So with that, things go down, and this is footer, and here we have the article, and here we have the header. So as you can see, the header is right on top. Article takes the whole space that's left in the app, so now I can resize my app, and the footer stays there, and the article takes the whole space. Awesome. So with this, we can come over here and start defining how our header is supposed to take space. We have some padding on the top, some padding on the sides, and then it's gonna be with flex, and we're just gonna rearrange some elements in this one, depending on the screen size. So this is actually, to be honest, this app is not this version of the app, the version that's a little bit closer to being done. We're gonna play around with it tomorrow as well in Ryan Carniaro's stream. I really want to show him a little bit of the stuff that we're doing and how much Tauri and SolidJS work well together. It's gonna be pretty great, I believe. So it will be great if you guys showed up as well. Let's see, now I can create my little logo, which is not quite a logo because I'm not a designer. So my logo is actually just Pulsar written and a subtitle. And then here I can just say, yeah, just use my logo. It's incredible how some little background and some padding already starts making the app look a little bit more finished, even if there's nothing there to show, right? We're gonna add the scanner back. And then yeah, this we're gonna have inside the article at first this little strong is where we're gonna show the stats, so how fast we actually do stuff in Rust and how long does it take. And then we're gonna have below this little div where is the table of results are actually gonna come. So let's just prepare this over here. And then we can actually do the footer as well, because this is supposed to be a simple one. And the footer actually has a special little component, because the footer is actually where we're gonna have some external links. So what I did here is I created a safe link component, which simplifies a little bit of the stuff, and then I just add the target blank and the no opener. So I still want to keep the referrer, because I want to know I want to be able to know, like in one of these websites, if I have analytics or what, that they're coming from this app or not. And actually I don't like this API very much. We can actually do better. We can use the children in this case, and this can be, I think, children here should be JSX element like this, and then I'll just add here. And this is actually not a good form for SolidJS stuff. I don't know why I did this. We do not destruct things like this. In this case, it doesn't make any difference, because things don't get re-rendered here. So but if we were passing some values or something, we could get some stale stuff, which is never good. And down here I can just close the safe link, and see, just like that, it looks a little bit more like HTML, which is always a good thing. So let's do that here again. Pum pum pum. Okay, so now the footer is done, and I can do this. Great. So we have the footer here looking horrible. What did I do wrong? Yeah, perhaps this is not doing me any favors. And then what did I do? Why does it work there and not here? Let's debug this. Debugging some CSS in a Tauri stream, that's a bit frustrating. This microphone kind of annoys me when I'm typing. I don't know why I make typos. I don't actually even look at things when I'm typing, but for some reason I just put my fingers in the wrong place. Why are you going so long? Why are you going forever? Oh yeah. So are you all doing? I actually need to tweet that we are live. Let me see, where's my browser? There we go. Oops. Did not intend to do that. Okay, so now we look all right with this. Still doesn't look great. There's like this phantom one over here because we need to redo the scanner component. So the scanner one is already doing some invocation. We already have some stuff over here that's doing some logs and setting up some states. So but we actually could clean that up a little bit because we're gonna be using more we're gonna be using a store, and we can actually put this data at different places. So let me go for it a little bit. So the scan is gonna in the end look like this. We're gonna start with the window performance now, which is the most precise way I know to time something in the browser, in the JavaScript runtime actually. And we're gonna pass down the scope to the get your data as usual, and then we can get one more time the performance now once this promise goes. So what's gonna happen is we're gonna create this little timestamp here, and then the get your data is gonna block execution, and once it gets to the next line with the end, we're gonna have a new timestamp. So with that, we will be able to come here on, gonna have some props, and we can actually have already create the scanner props, which for now it's just gonna be a setter with an any. We're gonna change that as soon as we create the actual store, but Now we do this, and then in here we're gonna use the setScan data by create this new elapsed, and this is gonna be n minus the start. I'm sorry, this is a set store function actually. And then we are gonna set the file list to the list. And finally, we're gonna have a status that's gonna be idle. And as you can see, it's already getting a little bit clunky to work with. That's because we need to create a store. Actually, it's a good exercise for today. So let me stop this and stop monkey patching the types, and we can go and set up the store. So then I can show you how the data is gonna look like. I think that's better, right? lib-store. So the first thing we're gonna have is the data, of course, and the data is gonna have a file list, and the file list is gonna be a record of some strings, and either a string or a number. We're gonna do that a little bit better, but the folder list, which actually I should hoist it over here because then it's easier for us to refactor in the future. This folder stat is gonna come from a package called Tauri Specta. What's gonna happen is it's gonna create some types for us based on the things that based on our Rust commands. So then we have better type safety. But for now, we're gonna go with this, and then elapsed. As you know, it's gonna be a number. And final, we're gonna have two possible statuses, which is idle or scanning. Finally, there's gonna be also a stats, which is gonna be a string. So for that, we can then create an initial store. Type data. File list is gonna be an empty array for now. Elapsed is gonna be 0. Status is idle. And then stats is gonna be a computed property that is gonna take this dot elapsed, divide by 1000 because we're gonna have in milliseconds, and we are gonna make it only having 2 decimals. Then we can return that we scanned the length of the file list, directories, in whatever time span in seconds. And this is it. This is our store. So now, haha, how's it going, Alien? Yeah, we're actually coding some Solid here, more than Tauri at this point. So let's create a context. Did you finish already your stream with the Tauri, the Astro docs? Oh, what we're building, let me show you. So we have this little app. And Rust is compiling. So I have this little app that is a dependency scanner. So it's a Tauri app built with Solid in the front, and what happens is that I can select one of my directories, and I tell it to scan. It's gonna scan for a while, depending on how many files I have, and it's gonna come back with a list of node modules, and it's gonna give me also the size of each node modules. So this is what. So Rust took all my 126 directories and scanned in 15 seconds. So it gives me, okay, the size of each node module. So as you can see here, I even have the Astro fork. And I can go on and say, yeah, maybe this one I'm not gonna use anytime anymore. And I can delete these node modules, and bada bing, that's it. So that's the app we're building. To be honest, also I'm gonna showcase this app a little bit, and we're gonna dive into the final version tomorrow on the stream with Ryan. But now we're actually building this from scratch. So we started in the first one, and we set up. We use the starter. I actually have this pretty nice starter over here on my GitHub. That's what we actually used last time. So this starter helps out you getting familiar with Tauri, and it starts a Tauri app with a little extensions that you could use, and puts SolidJS as the front end with some Tailwind. So last stream we set this up. We had a very crude version of the app running already. We played around with some Rust, because Rust can be a little bit difficult. So we came here, I wrote like a few print screens and stuff, and on the next stream on Monday, I'm gonna write the whole code in Rust. So what I'm doing right now is trying to make the app that we had by the end of the first stream to look a little bit more like an app. So once we add the functionality, it goes. Yeah, so Tauri is pretty great. It actually helps you a lot on getting started with things. So for example, I didn't put much effort in it, but we already have the function invocation happening. What it does is, right here, I have this get dir data, and I just use this Tauri API, which is a promise that does the IPC to Rust, and it runs the native code that brings the native dialog up. So this one line is actually responsible to getting us the file system dialog. In the same way, we can do that with like notifications. I can use that to remove a directory and stuff like this. So it's pretty cool. Yeah, the DX is pretty great, and you actually have some nice TypeScript types that help you out on this. So you have it actually holds your hand pretty nicely. What's gonna do is we have most of the functionality that we don't even need to leave JavaScript to get most of that app working. The only thing that we need to code is the traversing the file system, jumping into every node modules, and then from every node module we take every single file, we measure it up, and then we create a list and send it back. This is the kind of stuff that there is no built-in API for, and we really needed Rust to have it working. But other than that, you can go pretty far with just the native APIs. You can have notification, you can have a bunch of stuff. And the thing that I like the most about Tauri, maybe not the thing that the thing that I like the most, but one thing that I like a lot is this. So by default, all the APIs are blocked, and you can come over here and say, yeah, I'm gonna do this. I'm gonna add to the allow list, so I'm gonna need the file system API, and then with this, you can get like you can define which APIs of the file system API you want to allow. So for example, yeah, a bit like Deno, I think, yeah. And then you have some nice autocompletes. Let's see if I get them here. Yeah, so you can have not quite this one, no. But we have some predefined scopes where you can say, yeah, this is only gonna be allowed access in the documents, for example. I don't know all of them by heart. I always need to check the docs, but essentially that's it. Let me see what I did in this one. Yeah, so it's an array actually of the available scopes. So here I'm actually saying, yeah, you can scan my entire document subdirectories, and that's great. Yeah, exactly. That's what the docs are for. So I don't need to memorize everything. So yeah, this is cool. And then you also have like a CSP by default. There's some stuff that you can define, like the size of the window where the app first loads, if you're gonna allow resizable or not, and this kind of stuff, which is pretty great. Then once you allow that, there are, let me see, yeah, everything is blocked, but let's see. I can get, for example, this one I think it's pretty interesting. The confirm one comes from Tauri Apps API dialog, I think. And then you can have, for example, you can define like the title of that confirmation dialog and so on, and you can even define the type where it can be an error, an info, or a warning. So it gives you all the options within your system to play around with it, so you don't even need to go to Rust in many cases. Yeah, the APIs are pretty nice. I think, yeah, Fabian Lars, I think he left already. He's a coworker of mine. He does a lot of Tauri work, and he helps me a lot most of the time figuring out the APIs and doing this kind of stuff. But most of the things are actually quite self-explanatory once you start looking at the code. I just ask when I just need to ask sometimes when I want to try something either stupid or weird, which I do a lot. So okay, back to the store. Let's create this app store. Yeah, so Otavio is one of my best friends, great macOS developer, and I'm happy to see him here playing around with SolidJS and in Rust. Yeah, so with Tauri you get all this by default, and you don't actually get to do much of the native stuff. To be honest, I don't know very much about the Swift part, but yeah. Okay, so we need to create a context. Yeah, what I'm gonna do is create the context, and then here we have the scan data. That's gonna be the data, and this is what my context is gonna pass forward to everything. So now I just need to create a store with my initial store. So this weird syntax is just because I want my store setter to auto update if I change something in my store. So I'm getting the runtime reference of the scan store. And because the create store returns a tuple, so the first value is the store and the second value is the setter. I'm getting the first value of the tuple and getting the type. So then TypeScript can give me the proper type of my function. Cool. And now I just need to create my custom hook. And then this is just like the little boilerplate that we write for every custom hook, Otávio. So I need to have my app wrapped in this provider in order to be able to use my scan functionality. And then with that, I can come back to my scanner, delete this thing over here because I'm not going to use it. And I can just import the scan store setter. And that's it. So now I have things ready. And yeah, for now, so for now, this is not gonna work because this is not implemented yet. I have no types for it, but eventually I will. So this getDearData is not returning anything. What's gonna happen is we're gonna implement on the next stream and things are gonna look better. But with that out of the way, we have actually I need to do a little bit more of the functionality. So we get the root scope. So this is what the file system API is doing. So we're gonna invoke this getDear. We're gonna invoke actually the open dialog, and the open dialog we're gonna say, we just want to get like a directory. I don't need you to be recursive because what we need right now is just a path of the root directory that we're gonna scan. And I don't want the user, I don't have like multiple functions, so they cannot set multiple scopes for a single search. Once that is done, we create the root scope, which is a local state. The scan time is not necessary anymore, and this has a scope, still the same thing. And then we have this little root scope display because I want to show in this button, once we select something, for example, here, I want to show here. And right now we're just outputting the raw scope. What we're gonna do is create this root scope because at some point it's gonna be like a very long string that's gonna break the app like it just did. And that's not what we wanna have. So I'm gonna create this derived state that is the root scope display. So what we're gonna do is I'm gonna assign the root scope to this, which is kind of a TypeScript quirk for dealing with signals, because TypeScript cannot infer that by the moment I do a function call, yeah, so what's gonna happen is that we're gonna call the getter multiple times here, and I just don't want it. I want it to, this type guard to work. What's gonna happen, what would happen if we didn't have this type guard? Actually, let me show you. So we have the root scope here, which works as a getter. And now what I actually want is to return the root scope length if it's over 30. And as you can see, TypeScript's already complaining because it cannot narrow the type of a function getter, because technically a function getter can return a different value as the code goes. So even though this type check is right on the line above, there's no guarantee that whenever we call it on the line below, it's still gonna be the same. So that's why we store in a value, in a variable, because then the type guard is gonna work. And because this variable gets redefined every time this scope starts, it's not gonna break Solid's reactivity. So if my string is too large, I'm not gonna type this. So if my string is too large, we're gonna create a substring out of it. If it's not, we're just gonna return it. And that's it, that's the root display. And with that, we can then change the whole thing. So let me just copy paste this horrible code over here, and we're gonna walk through it. So the switch is lifecycle component from SolidJS. So I'm just gonna import it. And the match as well. So it's basically pattern matching for JSX. So we refresh to see if things go as we want it. So what's gonna happen is in the form, we set up some flexbox. We're gonna prevent the form from the default stuff because we're still in a web view. So web things apply here. And the form automatically on submission, they navigate, and we don't want it to navigate. Then I'm just gonna, for the sake of debuggability, log that we're starting the scan. We can set the status for scanning, and then we can set the scan scope. Here we are asserting that this is gonna be defined, and then if the scope is selected, we are gonna show it. Otherwise we're just gonna show a fallback, that is the scan. So this is an exhaustive switch. And then we have the type button that we're making some colors. It's probably broken right now because we're not passing a bunch of stuff. So yeah, TypeScript doesn't like that. Let's go back to our app and instantiate our store. So now what we need to do is scan data and set scan data to my scan store. And then I can have this as items as a derived state, which is gonna be if the length of my scan store is higher than 0. So if I have some item at all. Once this is done, my scanner then can finally where's my scanner? My scanner can then finally receive what I call a set scan data, and the set scan data is here. Great. So once we're done, we have things updated and they're looking okay. Yeah, TypeScript be like that. So there's actually a very big issue about TypeScript on this, Alien. I was actually trying to bully Josh or Mateusz or Matt to fix that upstream, but it didn't work because nobody wants to touch that issue. Let me see. Where is it? It's an issue on, it's 500 something on the TypeScript repository. Let me see. So here we are. Is it? No, it's not this one. Maybe this one? Let me see. No, not quite. It's a very old issue. Yeah, it's a very long PR that nobody wants to touch it. I need to find it later. I'm gonna tweet that again. And I'll let you know. I'll tag you in. But essentially, that's an issue so old that I was in this conference with Josh Goldberg, and I said, look, this is the only thing that I don't want to do. I don't want to assert my types here. And Josh just started laughing. And he actually remembered the issue number by heart. So he just mentioned issue 5 to whatever. And he actually remembered which was. So, yeah. But then Josh himself, the maintainer of ESLint, told me, yeah, just ESLint disable and assert things. So yeah, I'm the guy that actually recommended Josh to tell people to. I'm the guy that actually got recommended by Josh to ignore ESLint. Anyways, so here we are. Things should work now. If I select crap, there you go. Our app is looking like an app, and with that, look, it even resizes as well. Nice. So with that, we are ready now to implement a little bit more of this stuff. Actually, I can add the pattern matching over here, because right now we already have all the stores defined. So we can actually play a little bit with more of a control flow in SolidJS. We are in here, and what we're gonna do is we're gonna show when scan data elapsed is more than 0, and oh, this is okay, that's why it was looking off. So now there you go. So now we are not gonna show any more the thing unless we actually do a search. And finally, we have some switch cases. Oh, see you later, Alien. We're about to wrap up as well. I just need to wrap this thing here. And thanks for coming, by the way. So we have our match statement. And this time, this switch is not going to be exhaustive. So what we're going to have is the scan data status. If it is scanning, we're gonna just say scanning. If it's not scanning, why? Ah, yeah, I missed the when, of course. So when they scan data, oh yeah, first, if we have items, we are gonna show it, and then later we have this catch where scan data status is idle and we don't have items. We show this one, which still applies. And here we have the results table, which is a component we haven't created. Yeah. Let me follow my own naming convention, perhaps. So this is a big one, actually, quite important. Let me bring all the imports we're gonna use. This one's gonna be much later. This one's gonna be much later. So with that, we get the props. Yeah, this one is perhaps better if we implement later. Let me see. This, yeah, we need to add some transitions. So let's wrap it up now. It's been an hour and we are ready. So the last thing we're gonna do is then start playing around with a few of the functionalities we have. So for example, we're gonna add the TableRow component. This is actually more than one component in a single file. So the TableRow component is gonna bring back a table row, and we have this deleteNodeModules, which is actually the callback that's gonna define if we're gonna delete or not. So let me grab this one. This one is a fun one to implement. So let's do it here. Function deleteNodeModules. This is gonna take a path as a string, and then it's gonna return an asynchronous function. And the shouldDelete is actually not gonna be used because this is gonna be the source of our create resource, which is a signal based on an asynchronous function. And now we're gonna check if the file exists, which is gonna use the exists method in Tauri. So Tauri is gonna use the native APIs to check if that path exists in our system. If that file exists, we're gonna ask the user if we should delete things. It's gonna be deleted. And once this goes, we can actually add some nice types to our confirmation dialog. So this is here, and then if we should delete, we're gonna give this little warning in the console for now. And then we're gonna call the remove dir directory with the path / node modules. And I like having the node modules here hard coded, because every time we're gonna delete always one node modules every time we call. So this is nice because path is dynamically generated. I'm always a little bit scared, especially when it's a recursive removal. So remove is gonna be it's gonna be no, because a promise is it's actually gonna reject the promise. So we don't even need to care about this one. either it gonna throw or not. So we need to catch it in another moment. So outside of all these conditions, we're gonna return false. And that's it, that's the delete function. So with this done, we have our table row. We just need to create the table. We have our delete module working. And yeah, and this trash bin icon is actually just a component that I can copy paste because there's nothing to it, just an SVG wrapper. So it's just a bin SVG component. So if I reload it, at least the trash bin should, yeah, trash bin warning is gone. Cat dir name is not gonna come today, and the format unit size as well. So we're gonna leave the table to finish up on the next stream, because then we're gonna have the types already working, and then with the commands, the things are gonna be coming from the right places. And that's the last thing we have to then show stuff on the screen. So with that, thank you very much for joining me today, and I hope to see you tomorrow on the Ryan Carniato stream. It's gonna be 9 p.m. if you're Central European time. It's gonna be 12 p.m. like lunchtime, midday if you are on PST, and all the others in between are gonna be, you can figure that out, sorry. And I'm gonna tweet the link, so make sure to have a look at that. And we're gonna be back on this particular stream and channel on Monday, because we're gonna do a lot of Rust, so make sure you're not gonna miss me taking a beat out of the Rust compiler. It always screams at me, it's kind of fun. So yeah, see you on the next one. Bye bye.